Okay, we have done equations with one variable. You have done equations with two variables. And remember, when you went to two variables, you had a Cartesian coordinate plane. And we did inequalities with one variable, and we graphed them on a straight line, a number line. Now we're going to have inequalities with two variables, which means, again, we are going to graph them on this Cartesian coordinate plane. Okay? So just like we started with some of our inequalities, and we started with some of our ordered pairs when we went into the Cartesian coordinate plane, we did ordered pairs to see if those ordered pairs made the equation true. We're going to start with the same principle with inequalities. So here is our equation. We have x minus 2y is less than or equal to 3. And then I have four ordered pairs, 0, 0, 0, 4, negative 6, 0, and 3, negative 3. Okay, so this is the origin, the first quadrant. On the x-axis at the negative side, and this one is in the fourth quadrant. Okay, so let's see what this gives us when we put this in. That means we have to plug these numbers into the x and the y. So 0 minus 2 times 0, is this less than or equal to 3? Well, this is 0. 0 is less than or equal to 3, yes, that one's true. So that one is a yes. That one is part of our solution. How about 0 and 4? So 0 minus 2 times 4, is that less than or equal to 3? Well, 0 minus 8 is a negative 8. Is negative 8 less than or equal to that? Yes, this is true. So this one is a yes. How about negative 6, 0? Well, we have a negative 6 minus 2 times 0 is less than or equal to 3. Well, this is 0, so negative 6 is less than or equal to 3. Yes, that is true. So this one also is yes, it's part of the solution. Now let's look at the last one. 3 minus 2 times negative 3, is this less than or equal to 3? Well, this is 3, negative 2 times negative 3 is a plus 6. And this gives you 9. Is 9 less than or equal to 3? No, that's a false statement, so this one is no. That is not part of your solution. So this just gets your feet wet as you're starting into these inequalities, because this testing of these ordered pairs is how we're going to discover which side of the line our solution lies. So let's look now at actually doing the graphing of these inequalities. Just like in so many things that we do in algebra, there is a very distinct process that is very helpful. And sometimes there's shortcuts you can take, but a lot of times those shortcuts can also be confusing. So as I'm going to go through this, first of all, I am going to give you the process that we're going to use. So first of all, you're going to graph the line. And there's certain things to remember. If your line is less than or equal or greater than or equal, the line is going to be solid. If it is less than or greater than, your line is a dashed line. This means it is not included in the solution. The solid line means it is included in the solution. So depending upon the type of an equation you're given will determine which way you might choose to operate. I'd like to choose, if it's a standard form equation, I choose xy intercepts. If it's a slope-intercept equation, I choose slope-intercept equation form of graphing. Okay? Then you have to shade the side of the line where the solution is. Okay. But how do you know where that solution is? Okay, and this is how we're going to do this. Actually, that's step 2 because I combined 1 and 2 together. You're going to use a test ordered pair to find out. Okay? If the line does not go through the origin, use 0, 0 as the ordered pair. If it goes through the origin, you'll have to choose a different one. Okay? So let's look at this equation. 2x minus 3y is less than or equal to 12. Well, less than or equal, so my line is going to be a solid line. Okay, that's the first thing I decide. My line is a solid line. I'm going to choose the ordered pairs for the x and y intercept to use to graph it. So for my y-intercept, if I put 0 in for the x, that means 2 times 0 is equal to 0. And I have negative 3 times y is less than or equal to 12. And therefore, divide by negative 3. And y is less than, y, well, just make it equal instead of that. Y is equal to negative 4. Therefore, that's one ordered pair. Now I'm going to put 0 in for the y. So I have 2x minus 3 times 0. Well, 3 times 0 is 0, so I have 2x is equal to 12. Divide by 2, and x is equal to 6. Therefore, I have my 2 ordered pairs, and I can now graph the line of the solution. And remember, it is a solid line. Okay? As you see, we've got to draw the hash marks so we can draw our line. 0, negative 4. There's my first ordered pair. And my second ordered pair is 6, 0. As you can see, this line does not go through 0, 0. 0, 0 is above my line, so I can choose the ordered pair 0, 0 and put it into my equation and see what happens. So 2 times 0 minus 3 times 0 is less than or equal to 12. Well, that is 0 minus 0 is 0. 0 is less than or equal to 12. Yes, this is a true statement. Therefore, my ordered pair is in my solution, so everything above this line is going to be where your solution lies. So you're going to shade above the line. So you see, it's a very precise process that gets you to this answer. We're going to do another one in the slope-intercept form. So you can see the same thing. We can use it whichever way we want. Okay, so we have y is less than negative 2/3 x plus 2. Okay. What kind of line is it going to be? Is it going to be a solid line or a dashed line? This one's going to be a dashed line because it's only less than. So my line is a dashed line. So that we've already decided. Now let's graph it using our slope-intercept form of graphing. Which means the first thing you do is graph the y-intercept My y-intercept is plus 2, so there's my y-intercept. Now you use your slope. From your y-intercept, you're going to go down 2 and then right 3. There's another point. Since this is a dashed line, again, as you can see, it does not go through 0, 0. And so I can use this one as my test value again. And it's kind of nice because you see you've got this side of the line and that side of the line. So let's do 0, 0. I have negative 2/3 times 0 plus 2, and that is 0 is my y. So I have 0 is less than, negative 2/3 times 0 is 0, and 0 plus 2 is 2. So 0 is less than 2, so this is a true statement. That means where this ordered pair is where your solution is, and that means you're going to shade this side of your line. Okay? So that's how you know what to do with graphing inequalities. Let's look at another one. Let's look at some of these special cases. They're actually easier to know. So let's see. What if I have x minus 3 is greater than or equal to 0? Well, I don't have any y, so this is a special case. So I've got to solve for my x first. So add my 3 to both sides. And I have x is greater than or equal to 3. Greater than or equal, so it's a solid line. Let's go ahead and graph this. If I graph x is equal to 3, that means I have a vertical line at 3. Why? Because to be equal to 3, all my x's have to be 3. My y can be anything I want it to be. Okay? So 3, 0, and 3, negative 3. That gives you a vertical line. Now it says that x is greater than or equal to 3. Well, this is equal to 3. Well, what's greater than 3? All I have to do is ask myself, is 4 greater than 3? Yes. Is 2 greater than 3? No. Therefore, my solution lies to this side of the line. Okay? Now let's look at another special case. That was a special case with x being the only variable. Now let's look at one with y being the only variable. Let's go with less than instead of greater than. Less than 4. Okay, the first step is to solve for your y again. There's no x's here, so there's only one variable. Y is less than 2. Okay, again, dashed or solid line, dashed line. And now our graph, 1, 2. Okay, so again, if we looked at the XY chart, my y's, we're looking for things related to 2, right? Well, if it's equal to 2, it has to be 2. And x can be anything you want. Therefore, if I have 2, 0, 2, and negative 2, 2, that makes that horizontal line, only it's not a line, it's a dashed line. Okay? So this is a dashed line, and now we need to know, is the solution above that line or below that line? It says that y has to be less than 2. So if I go up here at 3, is 3 less than 2? Nope, that's false. Is 0 less than 2? Yes. So my solution lies below. The next part wants you to actually try to figure out the inequality from the graph. So let's look at this. And they're not giving you real hard ones. So here's my graph. Okay, x and 3. What's happening here? Well, it's a solid line, so we know it's going to have equal, right? But is it going to be greater than or equal or less than or equal? In other words, which one of these symbols are we going to choose? Well, here's 2. 2 is less than 3. But I'm on the other side of my line, so it can't be less than, it has to be greater than. So x is greater than or equal to 3. Okay, let's look at another one. Okay, there's my xy. It says plus 1 is my y-intercept. My slope is going to be down 2 and over 1. And what I've been given is a dashed line. If it's a dashed line, it means that you either have a greater than or a less than to choose from. And this is the side that is shaded. So how do you know which one that is going to be? Well, here's my 0, 0. I haven't used it, so I can put that in there. 0, negative 2 times 0, plus 1. And it has to be true, right? So 0 and 1. What makes that true? Well, 0 is less than 1, therefore less than is the symbol that goes in there, okay? So this is it for your lesson on inequalities. You'll probably get tired of doing test values, but test values ensure that you get the correct answer. So good luck on this lesson and have fun.